Dear student, welcome to my channel. Topic of this video is classical cryptography, and in this video I am going to explain Plafair substitution method. Now let us start. Classical encryption techniques. Goal is to introduce basic concept and terminologies of encryption and to prepare us for modern cryptography. This is a classification of cryptography. Substitution technique. In my previous video, I have already explained shift cipher, scissor cipher and monoalphabetic cipher. Now in this video, I am going to explain the Plafair cipher. Plafair cipher, it is invented by Charles Wheatstone. It is diagram substitution cipher that encrypts pair of letters instead of single letter. A 5 by 5 matrix is created using a keyword, removing duplicate letters and filling in the rest of the alphabet. I and J are combined, or either we can use I or J. Encryption rules. Letters are paired and substitutions are based on position in the matrix. This method hides letter frequencies because it is using the bigram, therefore make it more secure than simple substitution cipher. It was historically used for military communication due to its simplicity and improved security over the scissor cipher. Now here 5 by 5 matrix is used. So in 5 by 5 matrix total locations are 25 and we have total 26 characters in our alphabet. Therefore we can use either I or J. Now here we are using the keyword Charles. As in Charles there is no repeated keywords, but if present we can remove that repeated things. Now here we first will fill CHARLES. After this we will try with the remaining alphabet. Now A is already covered, so B. C is already covered, D. E is already covered, F. G. H is already covered, I, J. K. L is covered, M, N. In this way we fill the matrix. So for example, if keyword is cipher, then we can use here CIPHER and we will fill the remaining alphabets. Plafair cipher diagram splitting rules. Remove the spaces from the plain text. Break the text into diagrams, that is nothing but pair of two letters. If a pair has repeating letters, insert a filler letter X between them. So this will easy to understand with the example. If the total number of letters is odd, add a filler X at the end to make it even. For example, now we see the variety type of example. For example, plain text is a 5 letter or odd number of characters are there. So we make the diagram like PL, then AI, and for last we are filling the X as a filler. For even number of words there is no need to fill. For example, battle, BATTLE. Even this double T is not allowed, so we will check that if such cases occur, what to do. 2 repeated characters in a row plain text. For example, balloon. So here we can't make BALL, OO and NX, but we require to use filler because 2 repetitive characters are not allowed. So here we are using first BA, then double L is not allowed, so we add X here, so it will become LX. Once we add LX, for the next 2 characters they are not repeating, so it's LO and next is ON. So it is not required that after repetition, there is insert X between the 2 repeated characters. We will see the situation and based on that we will either insert or not insert. Now see the bookkeeper, BOOK. Even 2 repeated characters are there, but when we make a diagram there is no repetition. Then KEEPER. Now 4 repeated characters, that is, for example, see this example 4A and double B. Now here we require almost to fill X, AX, AX, AX. Then last for we will take AB and for B, BX. So in this way we are making the diagram from the plain text using the rules. Now we will go for the encryption. Now for encryption 3 rules are there: same row, same column and different rows and column. So first we will see the same row. If both letters in the diagram are in the same row, replace each other with the letter to its right. If it is in the last letter in the row, wrap around to the first letter of the row. Now for example, just make the assumption that matrix is of ABCD, 5 characters are there in the row and our characters are CE. Now to encrypt, what we do, we will take C to D, that is next right character, and for E we will take the A. So CE will be enciphered as a DA. Now here we take the example, for example EB. So we will see encryption and decryption simultaneously. EB, E and B, they are in the same row. So for E we replaced with the S, so we are going in the right direction, and for B we are replacing the D, so we are getting SD. For SD decryption we go in the left direction. For S we will take E, and for B we will take the D. Now we see the NG. Now we can see that NG again are coming in the same row. So this is N and this is G. So for N right hand side is G, and for G right hand side is J. And in the reverse operation, when this GI is given, we are just going in the left direction. So for G we are going in N, and for J we are going for the G. That is, all directions are exactly opposite. Now next is the same column rule. Now just make assumption that these are in the same column, that is like M, R, G, V, K. If both letters are in the same column, replace each with the below it. If it is the last letter in the column, wrap around to the top letter of the column. For example, M, R, G, V, K. If V, K is there, so here V next character is K, and for K next character is M. So M, R, G, just make visualization that this is in the column, and we are going to the next, and for the last character we will see. Now see this DT. Now D and D, they are in the same column. So for D we replace with the M, and for T we replace with the Y. And in the decryption, if my is given, we are going in the exactly opposite direction. For TY, now T and Y in the same column. So for T we are taking for Y, and for Y we are taking the first, that is nothing but R. So it is YR. And when we are doing the decryption, so for Y we are taking in the reverse direction, which will comes as a T, and for R it will comes as a Y. Different rows and different column rule. If letters form a rectangle, replace each letter with the one in its own row but in the column of the another letter. For example, see me. Now here we can see that this M and E, they are not in the same row or same column, but they form a rectangle. So this rectangle gets formed. So here what we require to do, for M we replace by the same row, that is G, and the next character is E, we replace with the D. And so exactly opposite happens for the column indication in the decryption. So for G and D, so when G and D we will match, then we will go for the M, and for D we will go for the E. Next is ET. E and T, they again form this rectangle. So for E we replace with the D, and for T we replace with the O. Exactly opposite happens for the decryption. Now you can try for this example. Meet me at the bridge. So this is the diagram is already given, and this is the matrix, and this is the output for this. So you just try encryption and decryption simultaneously. One more example here, in which the keyword is monarch and remaining characters are filled, and the plain text is hello world. So HE, again LL is coming, so we are adding X, then next LO, WO, RL, and last D is filled with the X. So in this way diagram is created, and after that for each diagram we require to apply the encryption rules. So you also try for this example. Now we will see the features and limitation of Plafair Cipher. It uses a diagram, that is pair of letter instead of single letter. It increases the complexity compared to simple substitution cipher. 6-7 possible diagrams are there versus only 26 letters in monoalphabetic cipher. Now with the diagram, our frequency analysis will be a flat. It will not be like there should be variation. So it tried to make a flat. So when flat frequency analysis is there, it is difficult for the hacker to hack. Diagrams have less predictable frequency distribution compared to single letters. makes basic frequency based cryptanalysis harder. Playfair alters plaintext frequency patterns, making ciphertext distribution flatter and harder to analyze. Playfair does not completely flatten frequency distribution, some patterns still remain. So when some patterns are repeated in the plaintext, and the same mapping we will get in the ciphertext, and from that particular same type of papers, same type of pairs are frequently occur, so hacker can get the idea. So we will see the example for this. Repeated diagrams can still be detected and aiding the cryptanalysis. Once considered unbreakable due to its complexity, but later cryptanalysis method shows its vulnerabilities. For example, see meet me at noon. So for me we are getting ng, for me we are getting ng. So this is repeating. So whenever any pair comes, it will be mapped to the ng. So even if the frequency analysis is flat in case of, but here the pairs are making the vulnerability. Ciphertext occurs less predictably, but repeated diagrams reveal some structure. You can try for this also. Key is secret, plaintext is hello, matrix success Python. Now when the keyword you are using puzzle, at that time your keyword directly become puzzle, because you are not allowed to use repeated letters. And for meetings, even double E is there, but when you make the diagram, double E is not coming, so there is no need to fill the X. These are the references for the video. Thank you. So in next video I am going to explain polyalphabetic cipher. Thank you.